Hi everyone, welcome to this lecture. So this lecture is a second part of project 1. So in the project 1 of this section, we are learning how to implement data normalization and min-max scaling in Python. So the data has already been created. Now it's time to perform the splitting of the data. So in order to split the data, I will use a function train underscore test underscore split, and I will pass few input parameters. So the first input parameter is the value of x, that is my feature. The second is the value of y, and then the third is the test size is equals to 0.2. So this 0.2 means 20%. It means out of my total data, I will use 20% data as a testing data, and I will use 80% data as a training data. Next, I have passed random state is equals to 42. Now we know the importance of random state, that if I pass a random state to any value, I will be able to generate the same samples every time I run this code. So if I want to generate the same training and testing sample every time I run this cell, I need to pass some random state. So let's run this cell to perform the split. Now after splitting, I have 4 variables or 4 new values. That is the training component of the data, the testing component of the data, the training labels, and the testing label. Let's see the shape of the training data. So the shape of the training data is 8 by 2. It means out of the 10 samples, here we can see that we have generated 10 samples. So out of the 10 samples, I will use 8 as a training and only 2 samples as a testing. Now the data has been split. It's time to apply data normalization both on the training component and the testing component of the data. Now for data normalization, we will use min-max scaler. We know that in min-max scaler or in min-max scaling, if we select the range between 0 and 1, it will be the data normalization. That is, the data normalization is the special case of min-max scaling where the range is selected between 0 and 1. So in order to perform data normalization, I have to import min-max scaler. So that min-max scaler is present in sklearn.preprocessing. Let's run this cell to import min-max scaler. Now here I am instantiating my min-max scaler and I am calling the variable as SC. So now SC will represent my min-max scaling. Let's run this cell and I have assigned a variable SC. Now let's see what kind of input parameters we can pass to this min-max scaler. In order to see the number of input parameter, I have to see the document of min-max scaler. Now student, remember one very important thing. Anytime you want to see the document of any Python function, you have to pass this Python function to a help function, or you have to call a help function on this particular Python function. So if I call a help function on min-max scaler, I will be able to see the document of min-max scaler. So let's run this cell to see the document of min-max scaler. So if I scroll up, I can see the min-max scaler function here. So if I see this, the important input parameter is the feature range. The default value is 0 and 1. So if I want to transform my data from 0 and 1, I do not need to pass anything because this is the feature range which is set by default. Since in data normalization, I need a range between 0 and 1, therefore I will not pass anything to this function. So in this way, by calling a help function, we can see the document of any function. Now I have seen this document, that is the feature range is between 0 and 1. Now I do not need to pass anything and I can use this SC variable, which is the representative of min-max scaler, to my training and testing component of the data. Let's comment out this so that I can save the space here. Okay, now we have seen the document of min-max scaler. Now it's time to transform our training data to the normalized form. So the first step is that we have to fit this scaler to our training component. So here I am fitting my scaler to the training component. So look at the function, or look at this line of code, sc.fit, and here is my training component. So what fit will do with the training component? Fit will compute the minimum and maximum value of the data. So basically we know that in order to perform data normalization, we need the x-min or x max, that is the minimum and the maximum value of the data. So the fit function will calculate those minimum and maximum value. And after that, we will use the transform. Here I am using the fit. I have used the fit. And now it's time to transform the data according to the range of 0 and 1. So I have already calculated the minimum and maximum value using a function fit. So what transform will do? Transform will scale the data according to the maximum and minimum value. So let's run this cell to transform the data completely into the normalized form. Let's see the normalized form of data. Now we can see that the minimum value is 0 and 1 in the first column, and also in the second column, the minimum value is 0 and 1. Now we have transformed our training component of a data into the normalized form of the data. That is, we have applied data normalization on the training component. Let's see these two steps again. First, we apply fit and then transform. Fit computes the minimum and maximum value of the data, and transform scaling the data according to the maximum and minimum value which we have computed by using the fit function. Now let's confirm the minimum and maximum value of this scaled data. So if we see the maximum value is 1, so this is approximately, or this is very, very close to 1. And we can see that the minimum value is 0. So we have transformed our data between the range of 0 and 1. That is, we have performed data normalization on the training component. Okay, so here we first fit and then we transform the data. We can use fit and transform in a single line of code. If we want to use them in a single line of code, we can do this. That is, we have to perform sc.fit_transform. Here we are fitting and here we are transforming. So if I run this cell, so in this single line of code, we have done both fitting and transforming. If we want to see the data again, we can see that the data is still between 0 and 1. So you can use fit and transform separately, and you can also use fit and transform in a single line of code. So the next important step is transforming the test data into the normalized form. Now for test data, we will only use the transform. We will not use fit. The reason is that we have to avoid the important thing which is known as data leakage in machine learning. So what is the definition of data leakage in machine learning? So basically in data leakage during the training, machine able to see some part of the testing data as well. So that is not a good thing for the machine to see the testing data during the training. So in order to avoid this data leakage, we cannot use fit for the testing data. Fit is only for the training data. Fit cannot be used for the testing data. So for the testing data, we will use only the transform. So here we can see that this is the transformed form of our data. So we have learned how to perform the data normalization on the training and testing component. We see that for the training component, we have to use fit and transform, while on the testing component of the data, we cannot use the fit function. We will only use the transform function in order to avoid the data leakage. Now let's perform min-max scaling, and this time we can select the range between -1 and 1. Now it's time to transform our data between the range -1 and +1. So this time I am again instantiating min-max scaler, but this time I have to pass the input parameter feature range equals to -1 and 1. The reason is the default value is between 0 and 1. If I want to use any value other than the default value, I have to pass the feature range as an input parameter to this min-max scaling. So here I want to transform my data between -1 and 1. That is between -1 and 1. Therefore, the feature range selected is -1 and 1. So here I am instantiating the data. Now, according to the rule, first we will transform our training data. So for training data, we will use fit_transform. And now we can see our training data, and we can see that the minimum value is -1. The maximum value is 1. Similarly, the minimum value is -1 and the maximum value is +1. Now here we can check the minimum value, the maximum value, which is 1, and we can check also the minimum value, which is -1. Now it's time to transform our X data as well according to the range -1 and +1. And we know that we cannot use a fit function for the testing component in order to avoid the data leakage. So we will only use transform. Let's run this cell. And here we have transformed our scaling data, our testing data into the min-max scaling in the range between -1 and +1. If we see here testing data, its maximum value is 1.01, which is very close to 1, and its minimum value is minus 0.4. So in that case, we can see that it is inside the range of -1 and +1. We did not get -1 here because we have only 2 samples, but we are inside +1 and -1, which is quite acceptable. So in this project, we have learned how to perform data normalization and min-max scaling. Before data normalization and min-max scaling, we also learned how to create the data using a very important function known as make_classification. Another very important thing which we learn is that how to apply data normalization and min-max scaling to the training and testing component. We learn for the training component, we have to use fit transform. But for the testing component, we will only use transform in order to avoid data leakage. I hope you understood this project. Thanks for listening, and I will see you in the next lecture.